Hello everyone, happy to see you here. Welcome back to my channel. Today we have a very interesting equation a cubed plus a square equal to 36. We need to solve this equation for a, so if you have your solution, your answer, you can also write it in the comments below and then we will check our answers. Okay, so first of all, let's write the 36 on the left side. This is our first step, so let's start with that. So we have a cubed, so the same beginning, plus a square. And we have minus 36, okay, minus 36 equal to 0. Right now, we can express the 36 in a lot of ways, but the best way to express is just look closely on the left side. We have a cube and a square, so we have cube and square. Right now, let's try to express the 36, of course, is it possible, as a sum of cube and square. Let's do this. So on the right side, we can express the 36, of course, in a lot of ways, but the best way for us, of course, is 27 plus 9, okay, 27 plus 9. And a lot of students might be asking why 27 plus 9, because 27 from here, 27, we can write as 3 cube, yeah, and 9 we can write as 3 square, okay. And right now, let's do this. First of all, let's express the 36 as 27 plus 9. Let's do this right now. So we have a cube plus a square minus, we in parentheses, of course, we have 27 plus 9. Okay, I hope you understand this step. Right now, let's open parentheses real quick. We need to change this sign to the opposite one. So let's do it right now. So we have a cube plus a square minus 27 and minus 9 equal to 0. And right now, as I said before, we're gonna change this 27 by 3 cube, and this 9 we're gonna change by this 3 square. So let's do this. First of all, we have at the same beginning, so we have a cube plus a square minus, instead of 27 we write 3 cube, and instead of 9 we write 3 square equal to 0. Right now, as I said before, so we have a cube and we have 3 cubes, so we have 2 cubes, okay, 2 cubes, and right here we have a square and we have 3 square. So right now let's group it, okay? Let's group these elements. First of all, let's group our cubes. So we have a cube minus 3 cube from here, yeah, in parentheses. This is our first group. And we have plus, in other parentheses, we have difference of squares. So we have a square minus 3 square, okay? A square minus 3 square. Right now we need to know a basic algebra formula. Right here we have difference of cubes, right here we have difference of squares. So right now let's remember these both formulas. First of all, let's remember complicated formula a cube minus b cube. Okay, so a cube minus b cube. This is our first formula. How does it formula looks like? This formula looks like that. So we have a minus b, this is our first parenthesis, and in another parenthesis we have a square plus ab and plus b square. So this is our first formula. Right now, let's remember another one, difference of squares. So let's do it right here. But this is maybe the easy formula, I guess, because a lot of students know this formula, a square minus b square. Maybe this is like the most popular formula nowadays. So we have a minus b times a plus b. Okay, we know everything. We know how does this formula, how can we expand it, how can we expand this expression. So right now, let's try to simplify this expression from here. First of all, difference of 2 cubes. As a result, when we plug in it, we have a minus 3 in first parenthesis. In another parenthesis, a square plus 3a and plus 9. Okay, and in another parenthesis, another group right here, difference of squares, we have plus a minus 3, and a plus 3, equal to 0. Right now, let's look at this question from a different angle, so we don't need to expand it in terms of formulas. Right here, we have a long expression, but we have a lot of parentheses, but the main thing, we have one common expression, a minus 3 right here, and we have a minus 3 right here, so we can easily factor it as a common. So let's do it right now. Let's factor it. So I'm going to start right here on the left side. So we have a minus 3. Yeah, and in parentheses, I'm going to use this type of brackets, okay? I just want you to see these groups of these parentheses. So a square plus 3a and plus 9, this is our first parenthesis, and plus a plus 3 from here, plus a plus 3 from here, a plus 3 from here. And right here we close this bracket. So I really hope you understand it. We just factor this a minus 3. Right now, what do we need? We need to simplify this expression right here. Everything is great because right here we can easily get rid of these parentheses. We need to add all of the things in these brackets. So we have the same beginning, a minus 3. And in another parenthesis, we have the next thing. We have a squared plus 3a plus 9 without any changes because this parenthesis is positive. Okay, so we have a squared plus 3a and plus 9 and plus a and plus 3. So we need to simplify this expression equal to 0. Right now let's do it. So what do we have as a result? We have a minus 3, the same beginning, so a minus 3, we have the same beginning. And in another parenthesis, I'm going to use this type of brackets because we have a square, okay, a square plus 3a plus 4a plus 4a, and 9 plus 3 equal to 12, so plus 12 equal to 0. Right now we have a really great expression because we have a product, and the product of two parentheses equal to 0 when the first parenthesis equal to 0. So in our case we have a minus 3 equal to 0. So let's do this. Let's solve this first branch. So a minus 3 is equal to 0. Or in other parentheses, a squared plus 4a plus 12 equal to 0. So let's write the second branch. So we have a squared plus 4a plus 12 equal to 0. So we have two branches. First branch is easy branch because right here we can easily find our a first. So a first equal to 3 from here, yeah. So a first equal to 3. This is our first root of our question. And the second expression. This is our quadratic equation. I really hope you understand it. And the best way to solve it is to solve using discriminant. So let's do it. Let's start with discriminant. Every time I see a quadratic equation, every time I solve it in terms of discriminant. So we have d equal to b squared minus 4ac. d big square minus 4ac. Okay, let's plug in everything. We know everything from here because a equal to 1, yeah. B equal to 4 and C equal to 12. So right now let's plug in. We know everything. We know these coefficients. So let's start, for example, right here at this place. So B squared, so 4 squared minus 4 times A times C, 4 times 1 times 12. As a result of a discriminant equal to 16 minus 48. And this is equal to minus 32. This is our discriminant, and I hope you understand that this discriminant is less than 0, so it means that in this branch we don't have real number root. We have two complex roots. So how can we underline it? We can write that d is less than 0. So from here we have two complex root, but we need to solve this question completely. So right now let's find this complex root. So a second and a third. So a second and a third equal to, so we have minus b plus minus square root of d and all over to a. So equal to, so we have minus b, so we have minus 4 because b equal to 4, plus minus square root of discriminant, square root of, where do we have it? We have minus 32, so minus 32, our discriminant, and all over 2 times a. We can simplify this real quick. So we have minus 4, the same beginning, plus minus square root of minus 32. We can write as square root of 2 times 16 times minus 1. So we can easily split it, and then we simplify this. Okay, so we have minus 1 right here times 16 and times 2. And all over 2 times a, 2 times 1. Right now there's a really great property, a really great square root property, because when we have square root of a times b, we can write it as square root of a times square root of b. Okay, really great. And right now equal to, right here we have minus 4 plus minus, let's split it. So square root of minus 1 times square root of 16 and times square root of 2. But we can simplify a lot from here because square root of 16 equal to 4. This is our imaginary unit. This is our I. And then we can simplify it. Okay, let's do it. So minus 4 plus minus I times 4 times square root of 2. We can easily change an order, but without any changes right now. We can divide it by 2. We can divide this part by 2, so we can split it like minus 4 over 2 plus minus 4i square root of 2 over 2. And from here we have our two roots. So we have minus 2 plus minus 2i square root of 2, or 2 square root of 2 times I, doesn't matter. Let's write it, for example, like that. And these are our two complex roots. Right here we have our a second and a third, so we can write it our full answer. Let's do it right now. So our answer right here on the right bottom angle, let's do it. So we have our answer to this question. So a first equal to 3. Right now we're going to change this. A first equal to, we're going to check this. Okay, a first equal to 3, a second equal to minus 2 plus 2 square root of 2 times I, yeah, and a third equal to minus 2 square root of 2 times I. So we have three roots. These two roots are complex root, and this one root is real number root. And a lot of students might be asking, maybe we have more roots. It's really great question, because we can easily explain it without any problems, because in terms of math there is like a really great theorem which is called fundamental theorem of algebra, and I just want to rewrite my question. So a cube plus a square and equal to 36. So in a few words, like really quick, briefly, I'm gonna say, because maybe a lot of students watch this video right now, and here's like a really quick tip. Okay, so what do you need from here? You need to find out where do you have this highest power. So we have a cube, a square, and of course the highest power is 3. So the first thing you need to do, you just need to scan what the highest power do you have. In this question we have 3, so it means that you will have 3 roots in total. You don't know how many real number roots, how many complex roots, but the highest amount of roots, if I can say it like that, yeah, these are 3 roots. In our question we can easily prove it with this branch, because we have 3 roots, but sometimes happen you have only one real number root, two real, one complex, a lot of combinations, but according to fundamental theorem of algebra, this 3 means that you will have 3 roots in total, and we can easily prove it right here. Okay, so I don't want to tell you this exact theorem right here. I just want to give you a quick tip for students, because mostly students don't like learn theorems. And just a quick tip: you have equation a cube plus a square, the highest power 3, so it means I have 3 roots in total, not 4, not 5, not 6, only 3 roots. And for example, if you have like maybe a to the power 5 plus a to the power 4 equal to, for example, 1, then you might be thinking, okay, a to the power 5 roots in total. I don't know how many real number roots. Maybe you can have like 4 roots, but not 6, not 7. Okay, like a quick tip. Maybe this is it helps you a little bit on your exams. Okay, this is my tip. This is our answer. Finally, let's check real quick our a first equal to 3. So we have a cube plus a square equal to 36. So we have 3 cube plus 3 square equal to 36, and everything is great because 27 plus 9 equal to 36. So 36 equal to 36. So this is a great root. Everything is great. I don't want to check this complex root. Of course, if you want it, you can easily check it. It will be your homework. If you want to practice a complex root, you can easily check it. It was my solution to this question. I really hope you understand this class. If you do, you can easily leave your response in the comments below. It's also really appreciated. And if you still have any question, write a question in the comments below, because this community, we have a lot of teachers in this community, I guess, yeah, a lot of math teachers, and of course you can easily ask something. Everyone will help you with appreciation, with the pleasure. So it's up to you. Of course, thank you for your time. Have a great day. See you in the next videos.